language that is defined by a grammar. So given a grammar, we are going to understand what is the language. In terms of regular expressions, we'll write. Okay, so this is a set of production rules. Okay, so in everything you see, either in every rule, you can see a terminal. Okay, so either A or a B. A and B are terminals. So either a A or a B is present in every production rule. So we say A or B. To the power plus means one or more occurrence. To the power zero means asterisk means zero or more occurrence. Okay. So when A or B was optional, we might have had this asterisk. But as you can see, all production rules has a terminal symbol. So one terminal is mandatory. So we say A or B. Any one terminal should be there, but one or more occurrence should be there. Okay. So this is the language generated by this grammar is A plus A or B occurs one or more times. Okay, and this has two production rules. So X is a non-terminal. Okay, A and A are terminals. Later X can be replaced with AX, BX or epsilon. Okay, so when we try to generate string out of this, we'll know. So we'll start with S and we'll have a X. We'll always have a in between and then we'll have a X. Okay, X can be replaced again with AX and then A and X we'll say, and X will be replaced by epsilon. So similarly, in case I choose a BX over here, so B and X is replaced by an epsilon. As you can see, it is like A in between, anything occurs in front and anything occurs after. So it follows that pattern. So that is a substring language or substring FA. We have generated so many FAs, right? So anything prior, anything after. So it's AA should be present somewhere in the string. Okay, it could start. So directly I can say S, X. I can have AA same, or I can have a different branch also, because I'm not going to do any replacements. I had it at the same branch. So X directly I can replace it with epsilon also. So this is also a valid string in the language. So there is no condition on it should not start with or end with. So somewhere AA should be present in the string. So that's also a valid string. So the language generated is what? A or B occurs 0 or more times. A or B occurs 0 or more times. AA is sandwiched in between. So AA should occur. It's mandatory to occur somewhere in the string. Okay, so this is the language generated. And this grammar does not generate anything. We don't have any terminals at all. So it is a empty language. Okay, similar to a null string. This is a null language, empty language. Okay. And let us consider this grammar. So S, A, C, A, all are terminals. And C can be replaced by A, C, A or a B. Okay. So when you try replacing it, okay, when you try replacing it, this is capital C. The terminal cannot be replaced. It is a non-terminal. Okay. Capital C, remember. Okay, so you have S, A, capital C, and then A. And this capital C, again, I can choose whatever to replace. Okay, I can either replace it with ACA, or I can do it with B. Okay, so when you try to do it, so you can see that what happens. Then I can replace this capital C again with this is again A capital C or a B. Okay, so when I keep replacing, you will see this pattern. So since C can be replaced either with A capital C A, or C can be replaced with a B, right? So only when I substitute B last, it will be a last string will have only terminals. So I have to substitute B at last. And number of A's are balanced on either side. How many ever times you substitute, you keep writing C again and again. So A's are balanced. So it is like equal number of A's on either side, and the B and equal number of A's. Okay, so equal number of A's on either side. So that is the language, A power N, B and A power N. Okay. Fine, so this is a language that is generated by this grammar. Okay. And the other example is S tends to 0 S1 or epsilon. Whatever we did here, But since S can is here, B was a separate terminal, but here I've given epsilon. So it is like 0 occurs n times, 1 occurs n times. So that is what will happen. So you can say S replaced by 0, S and a 1. And again, S, how many ever times you replace it with 0, S and 1 till you substitute an epsilon. This is not going to end because your n string should not have non-terminals. It should have only terminals. So when you read this, epsilon has no value. You can, so it will be equal number of zeros followed by equal number of ones. Okay, so that is what. So a language will be 0 power n, 1 power n. Okay, for all n greater than or equal to 0. So this is our language. So given a grammar, we were able to understand what pattern of strings will it generate. So what strings will be part of the language. So this we were able to find.